Welcome back, folks. So you can see we've got our Anatek power supply back on the bench here. Now, the last video I did on this, and I'll leave a link to it, I said that the capacitors inside it were probably pretty good because they were high quality capacitors. But one of my subscribers, goes by the name of Def Bomb, he left a comment saying that the little Rubicon capacitors were probably due for a change. And when I saw the unusual performance of the turn on this side of the supply, I think, yeah, he may be right. So I went ahead and I ordered in capacitors. So it's just going to replace the small ones. I'm pretty sure those big sprogs are okay. I might even check them once we got the thing apart here, but let's just quickly get into this. I want to get the cover off it and have a look and see why we can easily get to the capacitors and replace them. And we'll get on with that. 1 second. Okay, so it looks like we can get to those capacitors right from these openings in the bottom here without having to remove the PCBs. So if you see, I've marked them. I don't know if you can see this well enough, but over here is one. Here's another one here. Here's one here. And there's one there. And I've marked them on both the PC boards. So it should just be an easy thing to pop them out, pop the new ones in. Now the new ones I got are Uni-Byte. All these ones in here were they're much older Rubicons, of course, but they're only rated for 85 degrees C. These Uni-Bytes are all 105 degrees C and rated at 5,000 hours. So let's go ahead and pull those out and put these in, and then I'm just going to go through and measure some of the ones that we pulled out, and I might loosen off these, a couple of these, pull them out and test them too to see if they're around about what they should be. All right, so I'm going to have to put this over on the soldering bench, but I'll be right back. All right, folks, I've got those little Rubicons switched out for the little Uni-Bytes. And now I've pulled out the big sprog capacitors. I'm going to test them. They're supposed to be, these ones here are 2400 UF at 50 volts. And these ones are 3300 at 60. According to the schematic, they're supposed to be 2400 at 50, but it looks like one was switched out previously. This one here that for 3300 at 60. Let's have a look at them. So this one's supposed to be 2400 at 50 volts. That's not going to work out. 1 second, I know what to do. I'll be right back. So I got these little silicone dots. I'm just going to put 4 of them on the back here. Stop this thing from sliding around. Maybe I don't need 4, maybe 2 will do fine. Let's go one more. And we go at all 4. Okay, that'll keep it relatively stable. All right, let me get that capacitor again. And it's reading 46 milliohms at 2,900 microfarads. Okay, let's try this one here. 2,900 microfarads at 49 milliohms. So all seem to be okay. Here's the last of those ones. The last of the 2400s. Okay, this one's closer to its rated value, 2480, 2490, 45 milliohms. And we'll go with this obvious replacement capacitor here. It's 3300 at 60 volts. Let's see what it measures at. Yeah, 22 milliohms. That's nice. And the value is great. So yeah, these are going to be fine. Now let's get some of those little ones that we pulled out and check them out too. Okay, this one here is supposed to be 100 UF. That's in microfarads. Yeah, 84. So it's definitely lost some value there, and it's up to 0.4 ohms. Okay, so that one is marginal. Okay, this one here is supposed to be 220 microfarads. This one's in better shape, but it is, you know, it's on the slippery slide. This one's supposed to be 220 as well. Yeah, it's a little bit worse than the other 220 one. This one's supposed to be 100. At 0.44 ohms, so not great. Yeah, this one's supposed to be 10. Let's see what the other ones look like. These are all supposed to be 10. So far we're reading about the same. Just as a matter of interest, let me get a couple of these Nichicons here. Okay, here's one of the 10 microfarad ones. Yeah, see the ESR is about 1/3 of what it was on those Rubicons. And here's a 100. They would need to have been done at some point in the future anyway. They're done now, so we'll see how it changes. But the 3300 UF capacitor may be the reason why we get the strange turn on that one side. This is going to charge at a different rate than the 2400. So anyway, let's put it all back together again and see if we didn't destroy it or not. Okay, we got it mostly reassembled here, and I'm just going to do a quick visual inspection of everything and make sure that all capacitors have been put in the right way. I changed the location of this capacitor, this 3300, to see if that changes the location of the strange behavior. And then we'll know that is the fault. I don't know where I'd find these capacitors right now. Maybe somebody has some new old stock somewhere, but it'd be quite a search. Okay, everything looks good. All these capacitors look like they're in the right way. The polarity is as mentioned on the board. And I checked the sprogs as I put them in one by one. So let's just bolt this heatsink back down and turn it on. See what happens. I've got a load set up to it, set up at 50 ohms. I've got the voltages turned all the way up, and I've got the currents turned all the way up. So we should be able to look at the turn on up to maximum current and maximum voltage and see if there's any change from before we recapped it. When we turn it on here, we'll see if I did the job right or if it blows up. So here goes nothing. Okay. All right, let's get the scope running. Okay, it's not blown up yet. So we'll try this channel first here. Ooh, it's a weird turn on. So that was happening over here, and now it's happening over here where I put the capacitor. Try it again. Yeah, not as weird, but weird. And now it's settled down. I guess the longer you leave it off, the more likely it is for that to happen. I think the capacitor just gets charged up. And, well, that's my theory. We'll try another one here. Yeah, so let's move it over the other side here. And yeah, it seems to be much better behaved, although I might be just imagining it. Yeah, I think that's it. That's the reason we got the little strange turn on, is because of that 3300 UF capacitor. I don't think it's going to cause any harm. It's just a little weird when you initially turn it on. Let's leave it off here for a second, and I'll come back after about 1 minute, and then I'll go back over to this side and see if it does the same sort of weird thing again. Okay, it's been several minutes, so we'll set here. Let's turn it on. No, look at that. Looks fine. Yeah, it looks weird. Yeah, I think it definitely has something to do with that capacitor, though, whatever it's doing, because before it was over here and the problem is on this channel, and now the capacitor's in this channel and the problems followed it over there. So that's my story, and I'm sticking to it. All right, thanks guys for joining me today. I don't know if these capacitors actually needed to be changed, to solve any problems or anything like that. But at some point in the future, they were going to fail. Yeah, you could see that some of them, the resistance was getting quite high on them, and the capacitance was getting a little bit low. So now the job is done. I don't have to worry about that anymore. The big capacitors are testing out just fine, and so I think we're good to go on this for quite a while. Probably do me for the rest of my life. And I'd like to shout out to Def Palms. Thanks for the suggestion. I really appreciate it. If you get a chance, I'll put a link down below to Def Palms' channel. He does some really awesome stuff, repairing older equipment. It's a great channel to have a look at. Give him a like and a subscribe if you haven't already. Well, thanks guys. We'll see you in the next one. Bye.